Okay, Precalculus, we start chapter 6. We start trigonometry. Sorry about the shadows, but the sun is out today. Um, here we go. There's going to be a couple of chapters of trigonometry. So I'm starting as if you've never even heard of an angle before or anything. The one thing I'm going to assume that you guys know from somewhere in your education is the word SOHCAHTOA, which helps you remember that sine is a ratio of two sides in a right triangle. Okay, this would be a right triangle. And let's say this is my angle that I'm talking about. We're talking about angle A. Well, there are three sides. There's an opposite side from that angle. There's an adjacent and a hypotenuse. And the hypotenuse, of course, is always across from the 90-degree angle, and therefore it's the largest side. And then the adjacent just ends up being the other side, right? There's an opposite and there's an adjacent that's not the hypotenuse. Hopefully you guys remember that. Here we go. I'm going all the way back to the beginning. An angle. It's created by rotating a ray about its end point. Okay, so there's a lot of terminology we're going to talk about in the first couple of pages here. So here's what I want you to do. I want you to draw an endpoint and a ray. Okay, and then I want you to think about leaving that where it is and then rotating that ray to create sort of a second ray, and that makes an angle happen, right? The angle is not all of this white space in between. The angle is these two rays right here, where this endpoint we tend to call a vertex. This one, the one where we started, we'll call it an initial side, and then over here we're going to call this the terminal side, as if some motion had happened. And that motion is it started here and it went that way until it finished there, creating the angle. Okay, lots and lots of terminology here. An angle is considered to be in standard position if the vertex is at the origin and its initial side lies on the positive x-axis. Okay, so I'm going to draw another picture up here. I'm going to go with the xy plane. There's my x, there's my y, and then I'm just going to draw a standard position up here. So that means the vertex got to be at the origin. The initial side is here, and then, it opens up to a terminal side somewhere. As long as the vertex is at the origin and the initial side's on the positive x-axis, that's standard position. Okay, some definitions. A positive angle, those rotate in the counterclockwise direction. That's not how you spell that. Counterclockwise direction. Okay, so if I have in standard position and there's my vertex, if I'm going to have a positive angle, it's got to go counterclockwise, so it opens up that way. That's a positive angle. Negative angles rotate in the clockwise direction. We just had to pick one, so we picked it that way. Positive opens up that way, and a negative angle would open down that way. All right, that's a positive angle. That's a negative angle. I'm going to introduce it now. We use theta a lot, so I'm going to put theta inside that angle to describe the angle. It's just a variable. It's a Greek symbol, theta. Angles that share a terminal side. They share a terminal side. That means they start someplace and then they land in the same place, regardless how many times it's been rotated around the circle. Those are called coterminal angles. Okay, so like a 10-degree angle and a 370-degree angle. I hope everybody knows it's 360 degrees to get all the way around a circle. Well, if I went 370 degrees, I would land in the same place as 10 degrees. Okay, the measure. Here we go. The measure of an angle refers to the amount of rotation from the initial side that happened to get to the terminal side. Now there's three ways we measure angles. We can measure angles in revolutions, which means an entire trip around the circle. We open up and we go all the way around the circle. That's one revolution. Or degrees, something that we're very familiar with here in the United States, and radians, something that's more mathy than degrees, which were kind of arbitrarily picked. All right, let's go to video number 2.